Good morning. I am Annapurna, working as an assistant professor in the Department of ECE at Institute of Aeronautical Engineering. Today we are going to study about bridges. What is the need of bridges? Why we are using bridges? And what are the different types of bridges are there? So coming to the bridges. Generally, bridge is formed with the help of electronic components. That is, if an electronic components are arranged in the form of a bridge network or in the form of a ring network, then that is called as a bridge. If electrical components are arranged in the form of a bridge or ring structure, then that electrical circuit is called as a bridge. In general, bridge forms a loop with set of 4 arms or branches. Each branch may contain 1 or 2 electrical components. Here in this bridge network also we have 4 arms. This is first arm and that is represented by resistance R1. The first arm consists of a resistance, and second arm, this is second arm, which is also consists of resistance, that is represented with R2. This is third arm, represented with the resistance R3, and fourth arm is represented with the resistance R4. So finally we have this bridge, and this bridge consists of 4 arms. Generally we have 2 types of bridges. These bridges are classified into 2 types, DC bridges and AC bridges. The main difference between DC and AC bridges is, in DC bridges we have discussed about only resistance, because we have so this is the construction of a bridge. In this bridge, the 2 arms of the bridge are connected to a potential or supply voltage, DC supply voltage, and the remaining 2 arms of the bridge is connected to a galvanometer. This is DC bridge. And coming to the AC bridge, in AC bridges, the 2 arms of the bridge are connected with an AC voltage, whereas the remaining 2 arms are connected to galvanometer or detector mount. So we have finally 2 types of bridges, AC and DC bridges. Whether it is an AC bridge or DC bridge, the bridge always consists of 4 arms. Arm 1, arm 2, arm 3 and arm 4. These are the 4 arms of a bridge network. And this is a DC bridge. With the help of DC bridges, we can measure resistance. And by using AC bridges, we can measure resistance. Along with this resistance, we can also measure inductance and capacitance. Inductance and capacitance. So coming to this DC bridge, with the help, coming to this DC bridge consists of 4 arms, first arm, second arm, third and fourth arm. And the bridge is present in the balanced condition. When the bridge is in the balanced condition, we can measure the unknown parameter. For example, if you consider any bridge, the bridge consists of 4 arms. In those 4 arms, the 3 arms having known resistance values, whereas 4th arm having unknown parameter. This unknown, 3 are known parameters, this 4th is unknown parameter. This unknown parameter can be measured with the help of 3 known parameters. So to find out this unknown parameter, with the help of 4 known parameters, we have to follow the balanced bridge condition. The balanced bridge condition. With that help, we can measure this unknown parameter by known parameters. If the bridge is present in balanced condition. For example, if the bridge is in the unbalanced condition, when the bridge is in the unbalanced condition means we can measure the current which is passing through the galvanometer. Only 2 conditions, whether The bridge is present in the balanced condition or it is present in unbalanced condition. If the bridge is present in the balanced condition means we need to measure the unknown parameters. Among the bridge 4 arms, the 3 arms are known parameter. Having known parameters, only one arm consists of unknown parameters. That unknown parameters can be measured with the help of known parameters by using balanced bridge condition. Similarly, if the bridge is in the unbalanced condition, then we can measure the current passing through the galvanometer. So, in this DC bridge, we can measure resistance value. The first is, this is AC bridge. In this AC bridge, instead of resistances, each arm consists of impedance. 4 arms. A bridge consists of 4 arms. So here we have across each arm an impedance. It is represented with an impedance. The first arm having the impedance Z1, second arm have the impedance Z2, third arm have the impedance Z3 and fourth arm having the impedance Z4. So in DC bridges, each arm consists of only resistance, whereas in AC bridges, each arm consists of impedance. And along with this, the two opposite arms are connected to an AC voltage. Similarly, the remaining 2 arms are connected to detector mount. This is the construction of an AC bridge. Coming to the DC bridges, in this we can measure the resistance. The DC bridge which is used to measure the unknown resistance is the Wheatstone bridge. This is the construction of Wheatstone bridge. Similar to the remaining bridges, the Wheatstone bridge also consists of 4 arms, arm 1, arm 2, arm 3 and arm 4. The first arm having the resistance R1, and second arm also consists of resistance R2, third arm resistance R3, and across the fourth arm we have represented with a resistance arm 4. So, this is the Wheatstone bridge. In this, the first 3 resistances, we know the value of R1, R2, R3. We need to calculate the value of the resistance R4. To measure this unknown resistance, we have to consider balanced bridge condition when the bridge is present in balanced condition. So, to find out this balanced bridge condition, assume that the bridge is present in the balanced condition. The supply voltage V is passing through the bridge. Whenever the supply voltage V passing through the bridge, at the point A, the total current is present is I, then that is distributed as I1 and I2. So, total current A is equally distributed among the first and second arms. Then we can say that I1 into R1 equal to I2 into R2. Because I1 is equal to I2. Here, the current passing across the 2 arms are same. So, I1 equal to I2. Then, with this condition, we can represent the voltage or potential at the point D as total voltage into the potential at the point T can be represented as V1 equal to I. The current across passing through this potential is I1 into total resistance, that is R3 by R3 plus R1. Similarly, at the point P we can represent it as V2 equal to I2 into total opposite resistance R4 R2 plus R4. Then we know that V1 into I1 equal to V2 into I2 because I1 equal to I2, equal current flowing across these 2 arms. Then substitute V1 value here, then we have I1 into R3 by R1 plus R3, which is equal to Then we have 3R2 plus R3 into R4 equal to, by cross multiplying this equation, R4 R1 plus R3 R4. R3 R4 R3 R4 will get cancelled on both sides. Then we have R2 equal to R1 into R4 by R4. This is the balanced condition for the bridge. That is R3 into R2 equal to R1 R4. The same expression can be rewritten in terms of unknown resistance is, unknown parameter is R4. So R4 equal to R2 into R3 by R1. Or if you want to measure the resistance R2 means R1 R4 by R3. So the balanced condition for the bridge is unknown resistance R4 equal to R2 into R3 by R1. So to obtain this balanced bridge condition, initially we are assuming that equal current will be passing across first and second arms, that is I1 and I2. So we know that from this condition I1 is equal to I2. When I1 is equal to I2, then we have the voltage or the potential at the point D can be represented as V equal to I into R. So I into the potential at the point D is, the potential at the point D can be represented as V equal to I1 into total current passing across this opposite resistance by sum of the resistances, that is R3 by R1 plus R3. So we have V1 equal to I1 into R3 by R1 plus R3. Similarly, the potential at the point B can be represented as, the potential at that point is current I2 into opposite resistance is what? R4. So I2 into R4 by total resistances R2 plus R4. So V1 is this one and this is V2. But we know that as the current across the two arms are same, I1 equal to I2, so that we can conclude that V1 I1 equal to V2 into I2. We have the condition that V1 into I1 equal to V2 into I2. Or from this, V1 means I1 into R3 plus by R3 plus R1 equal to, this is I2 into R4 by R2 plus R4. As we know that I1 equal to I2, we have R3 by R1 plus R3 equal to R4 by R2 plus R4. By cross multiplying this equation, we have R3 R4 plus R1 R4 equal to R2 into R3 plus R4 into R3. In this equation, the term R4, R3 will be present in both sides. So this term will be cancelled. Finally, we have R1, R4 equal to R2 into R3. But the unknown parameter it is R4. So R4 equal to R2, R3 by R1. From this we can say that the balanced condition for the bridge, when the bridge is present in balanced condition, to measure unknown parameter is equal to R2, R3 by R1. So this is how to measure the unknown parameter if the bridge is present in the balanced condition. And the same can be obtained as when the bridge is present in the balanced condition, we have one formula, that is product of two opposite arms must be same. Here we have four arms. The two opposite arms means R1 and R4 are two opposite arms. So we can represent this with R1 into R4. Similarly, R2 and R3 are also two opposite arms. that can be represented as R2, R3. This is product of two opposite arms, that is R1 into R4. Product of the remaining two opposite arms, R2, R3. So, product of two opposite arms must be equal. That is R1, R4 equal to R2, R3. From this, if the unknown parameter is R4, then we can conclude that R4 equal to R2, R3 by R1. And the same can be obtained if we assume that the total current is I and that is equally distributed between the two arms of a Wheatstone bridge. Then we can find out unknown parameter R4 equal to R2, R3 by R1. So, the Wheatstone bridge is used to measure the resistance value. Only moderate resistance can be measured by using Wheatstone bridge. If the resistance is too small or if the resistance value is too high, we cannot find out with the help of Wheatstone bridge. In such cases, we go for another bridge that is called as Kelvin bridge. Now, this Wheatstone bridge is the balanced Wheatstone bridge. We have two more bridges related to the Wheatstone bridge. Those two are unbalanced Wheatstone bridge and slightly unbalanced Wheatstone bridge. Next, coming to the unbalanced Wheatstone bridge. Unbalanced Wheatstone bridge. In this unbalanced Wheatstone bridge also, we are considering that the bridge consists of 4 arms and similar to the previous case, in this case also the bridge consists of 4 arms R1, R2, R3 and R4. These are the 4 arms of a bridge and the 2 arms are connected to galvanometer whereas the remaining 2 are connected to the supply voltage. But in this case, the bridge is present in unbalanced condition. When the bridge is present in the unbalanced condition, instead of measuring unknown parameter, here we need to calculate the current passing through the circuit. So, to measure the current passing through the galvanometer, the current, we know that current I equal to V by R. So, to find out the current passing through the galvanometer, we need to calculate total voltage and total resistance. To measure total voltage and total resistance present across the circuit, we are considering Thevenin's equivalent. With the help of Thevenin's equivalent, we need to measure Thevenin's voltage and Thevenin's resistance. With the help of Thevenin's voltage and resistance, we can find out V Thevenins and R Thevenins. By this, finally, we can calculate the current passing through the galvanometer. So, first of all, to measure Thevenin's voltage, we are assuming that the 4 arms of the bridge are represented with R1, R2, R3, R4. This is where we have placing the galvanometer across the AB terminals. So, V Thevenins at this galvanometer the current passing through the galvanometer is nothing but V by I. So, voltage across this point is V Thevenins are nothing but EAB. The potential at the point EAB can be represented as potential at the point A minus potential at the point B. EA minus EB. So, to measure V Thevenins at A and V Thevenins at B and finally Thevenin's voltage at A minus Thevenin's voltage at B. To find out V Thevenins at A, V Thevenins at this point can be represented as total voltage across this point A into opposite resistance by sum of the resistances across this point, that is total voltage is E. E Thevenins at A can be represented as the total supply voltage at this point E into opposite resistance, that is R3 by sum of the resistance across this potential, that is R1 plus R3. Similarly, measure B. Thevenin's voltage at B can be represented as total voltage E into opposite resistance by sum of the resistances. Now, E Thevenins at AB can be represented as EA minus EB or EB minus EA. That depends upon magnitude. So we have E Thevenins at AB equal to E into R3 by R3 plus R1 minus R4 by R4 plus R2. This is V Thevenins at AB. Similarly, we need to measure current resistance R Thevenins. To measure this R Thevenins, we have to consider Thevenins resistance. While measuring the Thevenins resistance, we are assuming that the resistance across this potential is very small and assume it as 0 ohms. This is the resistance present across the potential. So the circuit can be redrawn like this. In this circuit, R Thevenins can be calculated as R Thevenins is equal to, see all the resistances. This resistance R1 is in parallel with R2. Similarly, resistance R1 is in parallel with R3. This is R3. Similarly, this is R2 and R4. Now, R1, R3 are parallel. R2, R4 also parallel. But the combination of R1, R3 is in series with the R2, R4. So, we can represent, if the two resistances are in parallel, then we can represent it as, the two resistances are nothing but R1, R3. If R1, R3 are in parallel with each other, then we have R1 into R3 by R1 plus R3, which are in series with the parallel combination of R2, R4, that is R2, R4 by R2 plus R4. If any two resistances are parallel, then product of two resistances by sum of the resistances, that is R1 into R3 by R1 plus R3. Similarly, if two resistances are in series, if the two resistances are R1, R2, then we have R1 plus R2. Now, R1, R3 by R1 plus R3 plus R2, R4 by R2 plus R4. With this, we can measure I Thevenins as current passing through the galvanometer can be represented as V Thevenins by R Thevenins. Whereas if you want to get I Thevenins, V Thevenins by R Thevenins plus current passing through the galvanometer. This is how to measure current which is passing through the galvanometer when the bridge is present in unbalanced condition. By measuring V Thevenins and R Thevenins, finally I equal to V by R. With this we can measure current passing through the galvanometer. So we have discussed about bridges. What is the need of bridge? What are the different types of bridges we have? Bridges are mainly used to measure unknown parameters like resistance, inductance and capacitance. The resistance can be measured with the help of either AC or DC bridges, but to measure inductance and capacitance, we go for the AC bridges. Normally, we have two types of bridges, AC bridges and DC bridges. DC bridges are used only to measure resistance, whereas AC bridges can be used to measure inductance and capacitance. So that's why across each arm we are representing the AC bridge with an impedance. Coming to the DC bridges, we are studying about this Wheatstone bridge. This Wheatstone bridge is used to measure unknown resistance. Only moderate value of resistance can be measured with the help of Wheatstone bridge. This is balanced Wheatstone bridge. If the bridge is present in the balanced condition, among the four arms, only one arm is unknown arm. So if the bridge is present in the balanced condition, we need to calculate that unknown arm. But if the bridge is present in unbalanced condition, then we need to calculate the current passing through the galvanometer. This is about balanced and unbalanced conditions that are present in Wheatstone bridge to measure unknown resistance. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.